Alright, ladies and gentlemen, welcome to a video tutorial. This is the introduction video for the Computing Olympiad algorithm tutorial series. In this video, I will introduce what is Computing Olympiad, some basic ideas, and how this tutorial series work. So first of all, what is Computing Olympiad? To make it simple, it is to write programs to solve given problems. So you see, programming is the central theme. And by programming, I mean there are no graphic user interface. You don't need to know how to make beautiful pictures in your programs. You only have to deal with only simple inputs and outputs. And in Windows, it is like the DOS Windows, where you only input characters or numbers, and they are beautifully simple. If you are passionate in computer science, programming, and problem solving, Computing Olympiad is for you. And this tutorial series will help you to master all these algorithms, and you can be an expert in Computing Olympiad. So how do we compete and judge? Say there are different types of problems, but most of the time we are still dealing with the traditional type, which is to compile and run the contestants' codes. And a contestant scores each time their programs produce the correct answer for each official test case as input. So you take their input and you give a right output, you score. If not, you fail. The program submitted by the contestants must not request more memory than allowed. Say you are not allowed to request huge arrays or write super complex recursions that exceed the memory limit. For each test case, the program must output the answer within the time limit. Usually it's 1 second, otherwise it won't be scored. Say how to make our program come up with the correct answer within the time limit and memory limit is what all of these algorithms that will be introduced in the following videos are for. So there are other types of the problems as well, but unless we go to IOI, the International Olympiad for Informatics, unless you go to that level, you are not going to encounter these like special judge, answer submission, and interactive. These are really high-level Computing Olympiad problems, and usually we are just dealing with traditional. Here are a few important Computing Olympiad competitions, like the IOI, which I just mentioned seconds ago. International Olympiad in Informatics is for high school and middle school students, and it's really difficult. In order to enroll, you have to get in the national team in the country you are from, and it's insanely competitive. At the highest level of Computing Olympiad, it's like the ultimate goal for almost all the Computing Olympiad participants. And there are also contests hosted by online judge like USCCO, the USA Computing Olympiad, and Code Forces, which are really popular online judge sites that have a lot of problems, and you can submit and see the scores, and also compete in the competitions regularly. Say specifically for USCCO, you have to get a really high rank in the highest division to get in the national team for United States in IOI. Okay, now we'll look at some terminologies. Say, I don't know if they are commonly used in the other countries, but back when I was in China, we'll all use these ACWRE, TLE, and MLE, these initials, yes, in English, for the different type of submission results. The AC is accepted, we all love that, and everything else are not accepted. WA for wrong answer, RE is runtime error, which happens if you divide by 0, or TLE, MLE, time or memory limit exceeded. For OJ stands for online judge, where you can submit codes to their problems and get some feedbacks online instantly. The POJ is organized by one of the best universities in China, and although it's in China, but 90% of the problems are in English, and we'll be using many problems in POJ later in these videos. And USCCO we just introduced, and Code Forces as well. Okay, now we're going to look at complexity, which is one of the most important idea for Computing Olympiad. Although I don't intend to make this introduction video a lecture, but complexity is really important, and we have to understand what it is in order to start working on the algorithms. The complexity describes the amount of time and memory, so they're separate, okay, a program takes. Lower complexity means higher efficiency. If the complexity is way too high, you'll get the memory or time limit exceeded. And time complexities, for example, O(n) means that the time required by an algorithm has linear relationship with the variable n. It may be n, maybe 2n or 0.1n that are all O(n), because when the n is large, we don't care about the coefficients, the coefficient constants. The O(n) square is like the square relationship. So if you write a nested loop, that's where you get an O(n) square complexity. And if the consumed time is a constant which would not vary with n, the complexity we call it O(1). And normally in C++, we can do 10 to the 8th power operations within 1 second. That is the limit, but this is just an indicator to see whether your program will work. So you plug in the maximum n provided by the problem and plug in into the complexity expression, and you'll see whether the number is greater than this standard or not. Well, sometimes the coefficient also matters. Say if the coefficient is really low, it's possible to pass a test case even if the complexity should not allow you to pass. But if your coefficient is way too great, you may even fail test cases where your complexity is low enough. That are all possible, but usually the complexity is what we're going to optimize. And memory complexity is very easy to estimate. Say, you know how much an int or char and double costs, right? So at the beginning, when you're designing and initializing these arrays, be careful that don't request too much memory. So if you request it too much, you won't get a score even for the very simple test case. So you need to keep an eye on that. You'll get a 0 if you made this simple mistake. Say, some competitions in China only allow you to submit 1, so you don't want to have this mistake ruin your competition. Okay, now we are going to have an overview for this Computing Olympiad algorithms tutorial. Say, in the following videos, I'll be introducing algorithms instead of programming languages. Well, you need to know at least one programming language to work. Usually the common languages like Java, C++, Python, all works. Pascal is a bit too old. If you're going to learn a new programming language, I would recommend to learn Java or C++. Say for this video's tutorial series, I'll be using C++ for all these coding demos, because C++ is the first language that I use, and there are many convenient aspects to C++. And C++ is really convenient in many ways. For all these algorithms, for each algorithm, there will be corresponding problem videos, which is Computing Olympiad problem tutorial videos for all of these algorithms to explain actual problems and how we are going to apply our algorithms into the actual competition problems. And I strongly encourage you to watch those as well, because unless you know how to apply these algorithms, they are not going to be helpful for you in competitions. Resources such as my sample codes and slides will be shared through Baidu NetDisk, or also called Baidu Cloud, Baidu Wangpan, or something like that. It's similar to Google Drive, but for the students living in China or other countries that censor Google, Baidu NetDisk is the only option. Okay, so now I'll give some resources for the C++ users. Say, in Windows, I would strongly recommend DVC++ as your compiler. Visual Studio is also fine, but it's not as simple as DVC++. So there are two versions, 4992 or 511. They are both okay in my book. And if you're using Mac, I recommend you use Xcode, which is a really, really powerful compiler for many languages. Down here, I have two header files. The header file screen.h and everything.h. So if you're not familiar with header file, they are basically what to include, the basic elements, the variables, constants, or libraries that you include at the beginning of the program. To use everything.h, you need to download screen.h and everything.h, put them into the directory where your program, the code.cpp file is in. And in the .cpp file, right, include double quotation mark everything.h. And it will include almost every header file you'll need in the Computing Olympiad problems. But you don't rely too much on it, because we cannot use these kind of header files when we're dealing with real competition problems. We only submit our own code, and we have to know that what kind of libraries are those operations or functions are in order to deal with real problems. So don't rely too much on it, but this is a really helpful tool that will simplify our work when we're learning, and I'll be using everything.h for all of these demos later in the series. Alright, that's it for this introduction video. In the following videos, I'll start to introduce the specific algorithms, and I'll write code for every single one of them to demonstrate how they work. Thank you.